Welcome back, Lesson C6, Division Property of Exponents, Standard EE1. What I want you to look at is writing out the following expression to simplify it, and we want to try and look for a shortcut. We talked about this in our very first lesson of the unit, but what does 4 to the 5th mean? It means that we have 5 4s being multiplied together, divided by 4 to the 3rd, which has 3 4s being multiplied. Now, when you're asked to simplify it, remember, 4 over 4 is the same as 1, another 4 over 4 is the same as 1, and 4 over 4 is the same as 1. And we are left with, for our answer, 4 times 4 over 1. How could we write that as a power? 4 to the 2nd, and our answer would actually be 16 in simplest form. What is the pattern or shortcut that you see? I want you to look at this and see if you could summarize it in your own words, and I'm also going to write it. And the key thing is that when we divide powers, I'm going to say, because remember, 4 to the 5th is a power, with the same base, divide powers with the same base. So these both had a base of 4. If they have the same base, instead of when we multiplied, we added, we are now going to subtract. So if we are thinking about this, we are subtracting the exponents when we divide. This is going to help us to do some simplifying when we have the same base in our numerator and denominator. On the second page down in your notes, here is our main property, dividing powers with the same base. To divide a power with the base, we subtract their exponents. A to the m over a to the n is going to give us that base a, subtracting our exponents m minus n. Remember, a, the base, can never be 0, and m and n are rational numbers. Here's a couple examples. 2 to the 6th over 2 to the 2nd, 2 to the 6th minus 2, 2 to the 4th, leaving our answer as a power. X to the 4th over x to the 7th. They always take the numerator, the 4 minus 7. We get a negative exponent, negative 3, and then we rewrite it positive. We're going to try these next ones. X to the 5th over x to the 2nd. At least in your notes, I want you to make sure you write down the rule that we're putting down 5 minus 2, simplifying it to be x to the 3rd. When you do your homework, I'm okay that you subtract that in your head. Again, we're going to do it with our m powers. We're going to have m to the 2 minus 5. Then we're going to have n to the 4 minus 3. Are we done with the problem? By no means. We now want to rewrite it. That is going to be m to the negative 3. And n, in this case, remember that was 4 minus 3 to the 1. Remember, we don't have to write an exponent of 1, and at this point it might be helpful to put it over 1. Our final answer would now be n. Positive exponent stays put. Where does the negative move? It's in the numerator. We need to move it to the denominator. And this would be our simplified answer. As you look at the next page of the notes, again, if you need to pause it to look at this, rewind it, look at the rule again. The top of the next page, we want to see how you can do. So, if you want to pause the video and try the first couple, and then check what I did, and then I'll ask you to pause it again. So again, I'm going to show my work on here. I know some of you won't. This is not just going to be m to the 6th. Remember, this exponent is a 1 even if it's not written there. M to the 5th. D to the 3 divided by d to the 3. Love that. 3 minus 3 is 0. Our answer is not 0 though. It's d to the 0, which equals 1. Again, try and pause it right now and do the next couple ones, and then you're going to hear me kind of work through it with you, but try it on your own first. Here, 6 minus 1, 2 minus 5. K to the 5th, j to the negative 3, can't have a negative exponent. We're going to rewrite it, thinking of it over 1. So my final answer, if I'm looking at that, is going to be k to the 5th divided by j to the 3rd. Again, if we're looking at this next one, again, if it helps you to pause it, do so. I'm going to do the work for these just down below the problem because there's kind of a lot. -3 minus 5. B to the 7 minus 2. We're going to end up with A to the -8, B to the 5th. Again, if it helps you, put it over 1. My final answer, the B is positive, it stays in the numerator. The A was negative in the numerator. It must move to the denominator to become a positive 8. The next one, x to the 4th over x to the 4th. Now we could subtract our powers, but what do we know if it's x to the 4th over x to the 4th, and that is exactly the same? That's the same as 1 over 1. What if you would have done x to the 4 minus 4? You would have got x to the 0. What's x to the 0? It is 1. We're working with our y powers. Y. And again, this time be careful with all these negatives. -1 minus 5. If you remember anything from last year, maybe subtraction can always be rewritten as plus a negative. So that's the same as -1 plus the -5. The last one that we're looking at, we're going to have that variable z, and it's going to be to the 8 minus 1. Well, we said we had x to the 0. Y is going to be to the -6. Z is to the 7. Well, that's 1 times y to the -6, z to the 7th. Think of it over 1. We now have to give our answer. It's going to be a fraction. I don't need to write the 1. Y is negative. If it's in the numerator, we got to move it to the denominator and make it a positive exponent. Z stays where it's at. I hope you were able to do those on your own, but if not, hopefully they kind of make a little more sense. We're going to look at a couple more problems in our notes. This next part down, as you looked at your notes, is kind of for you to read through, and then there's just one example we're going to look at. It says, what if you have a fraction raised to a power? Well, remember that quotient, then we look at that power tells us to put the x over y 3 times. So we put x to the 3rd and y to the 3rd. So here is our quotient rule. If you have something in a parenthesis raised to the power, raise each thing to that power as long as a is not 0 and b. So 3/5 to the 3rd, 3 to the 3rd over 5 to the 3rd, 27 over 125. Let's take a look at this one. It says we got to kind of combine all of our rules that we've been using now. So we are taking 4 to the 2nd, and we're taking p to the 3 to the 2nd. Well, remember, when we take it to that power, we're actually multiplying it. 4 to the 2nd is 16. P to the 3 times 2 is going to be p to the 6th in simplest form. You have a few more examples and some problems to look at. Again, if it helps you to pause it, go back and do that. Listen to it again. Look at the examples. Look how we wrote it. Take your time writing it so you can see your answer clearly. With all of these exponents and numbers, if you are not very clear, you can be sure that I'm not going to understand it and I can't give you the points. What happens with a negative exponent? We've talked about this earlier. To make it positive, we are taking the reciprocal. So a over b, the reciprocal, is b over a. So keeping in mind, it's that reciprocal. Make sure you add that to your notes. So we want to do this problem. First thing we're going to do is we want to rewrite it with a positive exponent. So if we are doing that, positive exponent means this is going to be to the positive 3. We're now going to have y to the 4th. And we're going to have 2 and x to the 6th. We have to raise each thing to that power. That means when I look at the problem, I'm taking y to the 4th and I'm multiplying it to the 3rd power. That's going to give us the y to the 12th. I'm going to take 2 and I have to take it to the 3rd power. 2 to the 3rd, this was one you memorized, that should be 8. X to the 6th raised to the 3rd. X to the 6th, not plus 3, but times 3. X to the 18th. Now, again, you can see mine writing with this pen, and on the board that I'm doing, it gets a little sloppy. I have to be able to tell this is an exponent and a base. This is what's called the coefficient, the number out in front of the variable that's being multiplied. So be really specific when you do your problems. Here again, we're going to practice the division and the powers and the negatives. Try it on your own first before you look at my answer, and then you'll see my solution. Here, to the 3 minus 10, y to the negative 7, can't have a negative exponent. My answer, 1 over y to the 7th. Again, go back, pause it, try it on your own. Please try this next one. There's a couple of ways of doing this one, and both of them work, so I'm going to show you both of them as we look at them. The first one is to take each one to the power, k to the third, k to the second, raised to the third. If I'm looking at that, that means I have k to the third divided by k to the sixth. Remember, our rule says to subtract, so if I'm looking at subtracting those, I'm taking 3 minus 6, which is going to give me k to the negative 3. Can I leave my answer in that form? No, I have to rewrite it as 1 over k to the third. Some of you might look at this problem and go, but Mrs. Thompson, it's the same base, k to the 1 over k to the second. So here is the other way you could do this. You could use your rule for division and go, oh, k to the 1 minus 2, all of that's to the third power. That's going to give us k to the negative 1 raised to the third. Well, what does it mean when it's raised to a power? We multiply those. When I take negative 1 times 3, I get the same thing I had here. Do I care which way you do it? No. I just want to see that you apply the rules. When we take this quiz and test on this, if I see the answer and it's wrong and I can't see any work, I will take off the 2 or 3 points. I can't give you anything. Whereas if you've kind of showed me your work and what you're thinking, I can at least give you a few points because I know you're on the right track. Negative exponent means reciprocal. N over m. N to the third over m to the third. The last one's a tough one. Please try it. Pause it now, try writing it out, then look at what I'm doing. Again, negative exponent, I like to switch that right away. So I'm going to have 5y to the fourth over 3x to the second. It's now to the fourth power. I'm taking 5 to the fourth. Y 4 to the fourth means I'm multiplying. 3 to the fourth. X 2 to the fourth. When I'm multiplying this out, I'm taking 5 to the fourth on my calculator. So remember, 5 raised to the fourth. That's going to give us 625. Y, 4 times 4 gives us 16. Denominator, 3 to the fourth gives us 81. Divided, and x to the 8th. Check it, go back, repeat it, look at it again. In class tomorrow, we'll be starting to look at the worksheet. Don't start ahead. We're going to do these in class, and I'll talk a little about them first.